kind of close with some other discoveries from my research group using computational cognitive modeling. Because again, the idea was that this is a tool, and we just walked through how to use this particular kind of mathy tool to investigate a question about WH dependency knowledge and its development and theories involving that. But there's other stuff that I've been working on in the acquisition domain that with this kind of tool that has yielded some kind of interesting insights and interesting discoveries. And I'm just going to briefly kind of highlight some of the ones that I thought were particularly fun. So for example, it turns out that children transform the input signal that they encounter in order to learn, right? Sometimes in particular, acquisition success may result only when the data intake that they take in from that input signal is a selective subset of the available input, right? And a number of different studies looking at this in basic word order, metrical stress, English anaphoric 1, syntactic islands, the English passive, where it's like, hey, you're not learning from everything that you could, right? Like you're actually selectively ignoring some stuff, and that seems to be important. However, sometimes acquisition success may also occur by taking a broader perspective on what might count as relevant data, and therefore what's taken in to learn from. And again, also in English anaphoric 1 and syntactic islands, and the passive, considering that actually other data may be relevant, actually turns out to be helpful. Also, children's knowledge during language development may be different than we originally thought, right? So to learn some types of linguistic knowledge, children may indeed need to have language-specific knowledge built into their minds. However, the exact form of it might be different than what we previously thought. And again, this is a variety of studies looking at different syntactic phenomena, English anaphoric 1 and syntactic islands, as well as linking theories, right? The connection between syntax and semantics, the link between that and argument structure. And also that children's linguistic knowledge may sometimes be far more well developed than we realize, earlier than we realize, with strong similarities between child and adult representations. And again, looking at this within closed class syntactic categories and quantifier scope interpretation, and when there's ambiguity, adjective ordering preferences, pronoun interpretation, just a variety of areas where it looks like kids are actually maybe more like adults in their knowledge than we thought. Another interesting idea is that different doesn't automatically mean quote unquote worse when it comes to language development. So, for example, if you look at input variation across socioeconomic status, it turns out that for at least syntactic islands, for example, the same learning outcome could still occur despite that variation. So interventions targeted at quote-unquote fixing the input because it's different and therefore worse, they aren't likely to be effective because while it is different, it doesn't seem to be worse, at least if this is the way that kids are learning about syntactic islands, for example. So it's kind of a nice finding, right, about like what's effective, what does different mean, how does it impact development. And another one is even if the representations of very young children may not match adult representations, they can still be good enough for helping other acquisition processes get started. We see this in early speech segmentation and early syntactic categorization. And finally, learners that have processing constraints, like children, may sometimes learn better than learners with fewer limitations. So this is, we have some examples of this in speech segmentation, but this is in line with the rather provocative and fun idea of less is more. Having less cognitive power actually yields better results, more language learning success, which is kind of a fun and interesting idea, is that children are particularly good at learning language precisely because they are limited in particular ways. And so the take home I'd like to leave you with is that, I hope anyway, is that computational cognitive modeling is one way to use math to investigate the magical process, I think, of child language acquisition. And it allows us to implement learning theories concretely, evaluate them, and better understand how they, and potentially therefore children, actually succeed at language acquisition. So let's keep using this wonderful tool to investigate child language acquisition and other areas of language that we find interesting. Thank you so much, and thanks to my wonderful colleagues and collaborators who were here, and all the other wonderful groups that I've told bits and pieces to of this project over time.